The morning it finally clicked was cold, quiet, and ordinary. A gray crossover rolled into my shop just after opening, exhaust puffing lightly in the air. The driver looked confused more than angry. "Nothing's wrong," he said. "No lights, no noises, but I'm burning fuel like crazy." And that is the most dangerous situation of all, when your car feels fine while a hidden problem quietly drains your tank every single mile. Today, I'm exposing exactly what that problem is. The shop was barely awake. Air compressors hadn't fully kicked in yet, the concrete still held the chill from the night, and the engine ticking echoed louder than usual as the car cooled down. From the outside, this vehicle looked healthy, clean, idle, no vibration, no hesitation when I blipped the throttle. If you drove it around the block, you'd swear it ran perfectly. And that is why this issue survives for so long. It doesn't announce itself. It hides behind smooth operation and normal behavior, quietly doing damage in the background. The driver leaned against the counter and told me the story I've heard hundreds of times. Same commute, same gas station, same driving habits. But the fuel gauge was dropping faster every week. What used to be a full work week on a tank had turned into 3, maybe 4 days. He'd already checked the basics, tire pressure, oil changes, even replaced the air filter early just in case. Nothing changed. The dealer told him everything was within spec. That phrase, within spec, has cost people more money than almost anything else in automotive history. I slid into the driver's seat and started the engine again, listening closely. There's a sound engines make when they're fighting something internally. Not a knock, not a rattle. More like restraint. Like the engine wants to respond but is being held back by invisible hands. The idle was smooth, almost too controlled, like the computer was working overtime to keep things civil. That's a clue most drivers never notice. I didn't start by looking for trouble codes. That's where most people go wrong. Modern cars are very good at hiding problems until they absolutely can't anymore. Instead, I plugged in the scan tool and watched live data. Fuel trims, load calculations, sensor response times. Numbers don't lie, but they also don't scream. They whisper, and you have to know how to listen. As the engine warmed up, the patterns started to emerge. Short-term fuel trims dancing higher than they should. Long-term trims slowly creeping upward, like a thermostat stuck too warm. Not enough to trigger a check engine light, not enough to fail an emissions test, but enough to burn extra fuel every single second the engine was running. This is the part most drivers never learn. Your car doesn't burn fuel based on how your foot feels on the pedal. It burns fuel based on what the computer thinks is happening. And the computer only knows what its sensors tell it. If one of those inputs is off, even slightly, the entire fuel strategy changes. The engine doesn't hesitate, it doesn't stumble, it compensates. And compensation costs fuel. The driver watched the screen over my shoulder and asked, "So, what does that mean?" I told him the truth. It means your engine thinks something is wrong, even though you cannot feel it. And when the engine thinks something is wrong, it protects itself by using more fuel. That is the core of this hidden problem. Protection mode without warning. No lights, no messages, just quiet overfueling. The scary part is how common this is. I have seen brand new cars do it. High mileage cars do it. Gas engines, hybrids, even diesels. Perfectly drivable vehicles losing 20%, sometimes 30% of their fuel economy with no obvious symptoms. Drivers blame traffic, weather, fuel quality, even themselves. Almost no one suspects the real cause because it lives in the blind spot between working and broken. I shut the engine off and let the silence hang for a moment. The driver looked nervous now, not because the problem sounded serious, but because it sounded invisible. Invisible problems are the most expensive ones because people keep driving, keep paying, and keep waiting for a warning that never comes. I explained that what was happening was not mechanical failure in the traditional sense. No broken parts, no leaks, no dramatic faults. It was a slow drift, a hidden imbalance, a system that had quietly moved away from ideal without ever crossing a line that would force the car to complain. And that is why this problem burns so much fuel before anyone notices. The engine still feels smooth. Acceleration still feels normal. The computer smooths everything out, but behind the scenes it is constantly adding just a little more fuel than necessary, a little more on startup, a little more during cruising, a little more every time you touch the throttle. Those small increases add up fast. By the time most drivers realize what is happening, they have already burned through hundreds of dollars they will never get back. And the longer it goes on, the more stress it puts on components that were never designed to handle constant overfueling, catalytic converters, spark plugs, oil quality, even internal engine wear. Standing there in that quiet shop, with a car that felt perfectly fine and numbers that told a very different story, I knew exactly what was happening. And more importantly, I knew the driver had no idea this hidden problem even existed. This is where it really begins, because once you understand what is actually causing your car to burn extra fuel, you will realize how many vehicles on the road right now are doing the exact same thing, and how easy it is to miss until it has already cost you a fortune. Most drivers never realize how thin the margin really is between an engine that runs efficiently and one that quietly wastes fuel every single mile. From the outside, everything looks fine. The car starts instantly. Idle is smooth. Acceleration feels normal. No warning lights, no strange noises, and yet fuel economy keeps slipping tank after tank. That is because modern engines are designed to hide problems. The computer's job is not to save you fuel, it is to keep the engine running smoothly at almost any cost. And when something goes wrong, the engine control unit will happily burn extra fuel to mask it. To understand why this hidden problem is so destructive, you have to understand how the engine thinks. Your engine does not burn fuel blindly. Every drop is calculated. The engine control unit constantly balances air, fuel, ignition timing, temperature, and load. It listens to sensors scattered across the intake, the exhaust, and the engine block. Those sensors act like the engine's senses, eyes, ears, and nose. If they report accurate information, the engine runs clean and efficient. But when one critical input starts lying, even slightly, the entire system spirals into compensation mode. This is where the hidden problem begins. It is not dramatic. It does not happen all at once. It starts as a tiny deviation, a slow sensor, a restricted airflow path, a pressure imbalance, or a component that no longer reacts fast enough. The engine control unit sees something it does not like. It does not know why, but it knows the mixture is not ideal. And when the engine control unit is uncertain, it always chooses the same solution: ADD fuel. Extra fuel is safety. Extra fuel prevents lean combustion. Extra fuel keeps temperatures down. Extra fuel keeps the engine from stumbling. But that safety comes straight out of your wallet. Every correction adds up. Short-term fuel trims begin working harder. Long-term trims slowly creep upward. At first, the numbers are small, 5%, 8%. Nothing you would notice. But as weeks turn into months, the corrections become permanent. Now the engine is burning 15, 20, sometimes 30% more fuel than it should, just to compensate for a problem you cannot feel. This is why drivers always say the same thing: it still feels normal. Of course it does. The engine control unit, the ECU, is doing its job. It is hiding the problem by throwing fuel at it. That is also why there is no check engine light. Warning lights are designed for failures, not inefficiencies. As long as sensor data stays within a plausible range, the ECU assumes everything is fine. It does not know the sensor is lazy. It does not know airflow is restricted. It does not know pressure is leaking or readings are delayed. It just reacts. And while it reacts, damage quietly builds. Rich combustion does not just waste fuel, it changes the chemistry inside your engine. Excess fuel washes oil off the cylinder walls. That accelerates wear. Unburned fuel raises exhaust temperatures, stressing the catalytic converter. Carbon forms faster on valves, pistons, and intake components. Spark plugs foul sooner. Oil gets diluted. All of this happens long before any dashboard light warns you. What makes this hidden problem especially dangerous is that it often mimics other issues. Poor miles per gallon gets blamed on bad gas, on winter fuel, on traffic, on age, on driving style. Some drivers replace spark plugs, others clean injectors, some even swap sensors that were not the cause. And every time the problem remains, because the real issue is upstream, buried inside a system most people never think to check. I have seen engines lose fuel economy not because something broke, but because something stopped responding at the speed the engine control unit expects. Modern engines operate in milliseconds. A sensor that is just slightly slow can throw the entire calculation off. A valve that sticks occasionally can disrupt airflow. A small restriction can change pressure just enough to confuse the computer. And once the engine control unit starts compensating, it keeps compensating even if conditions change. That is the trap. The longer this hidden problem exists, the more the engine control unit adapts around it. Fuel trims settle into a new normal. The engine feels consistent, predictable. But that new normal is expensive. You are paying for it every time you fill the tank. And because the engine still feels good, most drivers never go looking for the cause. They just accept worse mileage as part of owning an older car. But it does not have to be that way. The key is learning to stop looking for failures and start looking for behavior. Mechanics do not chase lights, they chase patterns. Fuel trims that should not be high, sensor signals that should not lag, airflow readings that do not match load. When you know what normal looks like, inefficiency stands out instantly. And the moment you identify the hidden problem, the fix is often far simpler and cheaper than anyone expects. Because this is not about replacing half the engine, it is about restoring balance. Getting the engine control unit accurate information again, letting the engine stop guessing and start running the way it was designed to. And that brings us to the most important part, how to identify this hidden problem on your own, without guessing, without throwing parts at the car, and without waiting for a warning light that may never come. Because once you see the signs, you will never look at fuel economy the same way again. The most quiet, fuel-wasting problems are never the ones that make noise. They are not the loud misfires, the flashing warning lights, or the dramatic breakdowns on the side of the road. They are the quiet ones, the ones that let your car feel normal while something inside is slowly bleeding efficiency away, mile after mile. And by the time most drivers realize what is happening, they have already burned through hundreds, sometimes thousands of dollars in extra fuel without ever knowing why. This is where everything finally connects. Your car is not just getting older. It is not suddenly inefficient because engines wear out at some magical mileage. Modern engines are designed to run efficiently for hundreds of thousands of miles, but only if the information feeding the computer stays accurate. The hidden problem we are talking about does not break suddenly. It drifts. It lies slowly. And the engine control unit believes it every single time. Once that bad information becomes the new normal, the engine adapts around it. Fuel trims climb. Injection times stretch. Combustion becomes dirtier. The car still starts, still idles, still drives. But the balance is gone. And when balance disappears, fuel economy is always the first thing to die. Here is the part most drivers never hear. The engine control unit is not smart in the way humans think. It does not question sensors. It does not doubt them. If a sensor says the engine needs more fuel, the engine control unit obeys, even if that sensor is wrong, even if the engine does not actually need it, even if the result is wasted fuel pouring out of the exhaust. The engine control unit's job is to protect the engine, not your wallet. So when data becomes questionable, it plays it safe by running richer. That safety net is what drains your tank. This is why the problem feels invisible. The ECU works overtime to hide it. It smooths idle, it compensates for timing, and it adjusts throttle behavior. It masks symptoms so well that drivers assume everything is fine, until the gas gauge starts dropping faster than it ever has before. And the longer this goes on, the worse the consequences become. Excess fuel doesn't just disappear. It washes down cylinder walls, thinning oil and accelerating wear. It creates carbon deposits on valves and pistons. It overheats catalytic converters that were never designed to process that much raw fuel. It stresses ignition components. Over time, what started as a fuel economy issue turns into an engine longevity issue. That's why fixing this hidden problem isn't just about saving money. It's about stopping damage before it becomes permanent. The good news is this. Once you know what to look for, the fix is almost always simpler than people expect. You do not start by throwing parts at the car. You start by observing behavior. Watch fuel trims, sensor response, and how quickly data changes when conditions change. That is how professionals do it, not by guessing, not by hoping, but by watching how the engine reacts in real time. When the faulty component is corrected, whether it is cleaned, recalibrated, or replaced, the change is immediate. Fuel trims settle down, exhaust smell normalizes, throttle response sharpens, miles per gallon climbs back toward where it should be. The engine feels lighter, freer, more responsive, not because you added power, but because you stopped wasting it. And this is the moment that shocks most drivers. They realize their car was not tired, it was not worn out, it was not just old, it was misinformed. And once the misinformation stopped, the engine went right back to doing what it was designed to do. Prevention matters just as much as repair. Clean air matters. Sealed intake systems matter. Healthy sensors matter. Short trips, dirty filters, and ignored maintenance intervals quietly shorten the lifespan of the very components that control fuel efficiency. The drivers who never experience sudden miles per gallon drops are not lucky. They are consistent. They maintain the systems that feed the engine control unit good data, and the engine control unit rewards them with efficiency. Most people never learn this. They keep driving, blaming fuel prices, blaming traffic, blaming the car. They adapt to worse mileage instead of fixing the cause. But now you know better. You know that when fuel economy collapses without warning, it is not random. It is not mysterious. It is a hidden problem quietly steering your engine in the wrong direction. And once you see it, you cannot unsee it. If this changed the way you think about fuel, engines, and efficiency, do not stop here. Subscribe for more real, mechanic-level breakdowns that save you money and protect your car long-term. Drop a comment with your car and mileage. I read them, and I help where I can. Your car has been talking the whole time. Now you finally know how to listen.